Hi, this is Math 7, Unit 6, Lesson 14, CUSD homework, finding solutions to inequalities in context. Alright, again, the first one is always your cool down, so I'll let you do that one there. Alright, so moving to number 2. It says Lynn's mom gave her $40 to order dinner. Lynn bought 3 medium pizzas and some breadsticks. The breadsticks cost $2.99. We don't know how many, she bought some, so we call that X, right? So there's that right there, and we know she bought some pizzas. Okay, write an inequality for this situation. Wow, that's an interesting problem there, right? So we know she has $40. Okay, we know she bought 3 pizzas, so 3 pizzas, but I don't know how much a pizza costs. I have no idea there. And some breadsticks, and the breadsticks cost $2.99. I wish I knew how much the pizzas cost. So what we know is that 3 pizzas plus well, I guess they're gonna say that's the cost, so I was working too hard there. Some breadsticks, doesn't matter how many, I guess they're just saying it costs $2.99. So we're gonna say that the pizza plus the breadstick costs $2.99. That price there, whatever that is, needs to be less than the amount of money she actually had. Okay, so 3 pizzas plus $2.99 needs to be less than the money she had, $40. So what amount is the most that each medium pizza could cost? Well, to solve this here, we're going to subtract 2.99 from both sides. And when we do that, again, you can kind of estimate here. This was 3, we'd say we have $37 left. So we know we actually have 37.01, which sounds silly, but that's how much we have there. And we're going to divide that, or say we said that amount is going to be greater than our 3 pizzas. So if I divide both sides by 3, the pizza value, the most that a pizza could cost, is 37.01 divided by 3, which in our case is 12 point, and I got 336, or about 12.34. Alright, so what's the most that each medium pizza could cost? Well, about $12.34 is going to put you over there. So we can't have it much more than that. So to think if that's being true, let's think if I did 12.34 and I multiply that by 3, I get 12 carry the 1, 9, 10 carry the 1, 6, 7, and 3. So 3702. So I'm actually too big there, right? That's going to be too much because I know I have to get to 301. So let's turn this to 12.33. Let's not round up because rounding up in this case is too expensive. So we're going to make that a 9, make that a 9. We have 37.99. We add 6. Oh, this is just 6. 36.99. We add to that the breadsticks, 2.99. We have 18. We have 19. We have 6, 7, 8, 9, and we have 3. So if the pizzas cost $12.33 each, and you bought 3 of them, and you did the breadsticks, you would spend $39.98, which keeps you under your $40 that you had. So that's the most that a pizza could cost. So I'm glad I checked that real quick because I had a 4, and I want to change it to a 3 so I actually stay under my budget. If I didn't do that, I would be over by 1 cent. If this was $12.34, I'd be adding 1 cent for each pizza, which is plus 0.03. And if I add 3 cents to that, I'm over. I'd have 40.01, and I can't buy it all. All right, number 3. Jada can spend at most $150 on clothes, so that's the max, right? She wants to buy a pair of jeans for $50 and spend the rest on sweatshirts. Each sweatshirt costs $20. So we want to figure out how many sweatshirts she could buy. So think of it this way. She has $150, right? She needs to make sure that she spends less than that, so that whatever she has needs to be less than that. That's the most she has is $150. This amount here has to be less than what she has. So she spends $50 on jeans plus sweatshirts, which are $20, but we don't know how many she can buy. The question, though, is going to be how many sweatshirts can she buy? So to solve this, what we want to think about is we subtract 50 from both sides. And I have 100 here. It's going to be greater than 20x. I'll divide 20 on both sides so that 5 is greater than x. Now what was X standing for? X was the number of sweatshirts she could buy. And so in our case here, we could say the most she could buy would be 5, right? And she could buy 5 sweatshirts there. Does that work? Well, let's come back here. If she bought 5 sweatshirts for $20 each, that's going to be $100. If she then bought the jeans for $50, she spent $150. Is that okay? Okay, we would say, yeah, that's going to be okay. And if anything, what I see here is that I probably should have done an equal sign there here. I probably should have also done it in the problem before, because you could use all $40. In this case here, she used all $150. So that's okay. So it can be greater than or equal to, because I don't need to have change left over. All right, number 4. The solution to negative 4x plus 7 is less than 35 is either this one or this one. Which solution is correct? And explain how you know. Alrighty, so which one's going to be correct? That's a great question. So, well, in this case it says that x is less than negative 7. In this case it says x is greater than negative 7 when you read that way. So the signs have been reversed. The numbers and the variables are the same, but the inequality sign is going a different way. Either, if you think about a number line here, right, and here's 0, and here's negative 7, x is either going to be this way, can be greater than negative 7, that's what choice B says, or it's going to be less than negative 7, which is what choice A says. Alright, so let's think about a number. Okay, think about a number less than, or let's think about a number greater than negative 7, like 0. Okay, can we use 0 real quick? For choice B, let's put 0 right here. I'm going to use 0 and see what happens. If I put a 0 right here, then what happens? 0 times 4 is nothing, and I'm left with 7. Is 7 less than 35? Yes, that's a true statement. So that one seems to be correct. But let's try a number over here that's going to be, in this case here, less than negative 7. Okay, so x is less than negative 7. I'm going to pick negative 10. Why 10? Because it's just a nice number. So negative 4 times negative 10 is a positive 40. And 40 plus 7 is 47. Is 47 less than 35? No, it's not. So the one that makes the most sense is choice B, and we tried it out with a number there to verify that it's true, and that's going to be our solution. Now again, if you're just looking at the picture here of what I've drawn, you might say, oh, it's B. But I want to explain how you know. And we talked through, how did I know? I picked some numbers to put into the inequality here to see what would make the most sense. Alright? Now, as a way of solving it, you could do negative 4x plus 7 is less than 35. You subtract 7, and you end up with, in this case here, you end up with 28 is greater than a negative 4x. And when you divide by a negative number, what has to happen is we do need to reverse our sign. X becomes greater than negative 7. 28 divided by negative 4 is negative 7. So that's the solution, but this is a way of proving that with some actual numbers. And the final problem today says, the school ordered 8 large boxes of pencils. This is a review. After giving 12 pencils to each of the 8 teachers, there were 304 pencils left. How many pencils were originally in the box? All right, so great little problem here, right? They ordered 8 large boxes of pencils. Okay, so they took the 8 pencils and they gave everybody 12 pencils to each teacher, and they had 304 pencils left. So how many were left in the box originally? Okay, so think of it like this. Everybody got 12. Well, or 8 people got 12. 1, 2, 3, 4, 5, 6, 7, 8. So 8 people got 12 pencils. Those are the teachers. And then we had a remaining part of 304 were left. What they're asking is how many were in the box originally. That's kind of the idea. Now the simple way to do this is notice that we have 1, 2, 3, 4, 5, 6, 7, 8 groups of 12. And we're going to add that to the 304. And when we do that, it should tell us what we're looking for how many there are altogether. So So I'll let you do that on your own. Good luck with that. Have a great day, and we'll see you next time.